Hello everyone, I am Tanisha Chhabra and we are the students at University of Windsor pursuing Masters of Applied Computing. This presentation is for the Web Search Engine project for the Advanced Computing Concepts class. This is the final project and it is developed using the Java language on the Eclipse IDE. So here are the contents of the presentation. First, we will tell about the team roles and give a brief introduction about the project. After that, we will explain all the features of the web search engine. Then the flowchart will explain the working of the project. It will be followed by a live demonstration on the Eclipse IDE, and in the end we will discuss about the future scope of this project. So here are the team members and their respective roles. We have individually worked on the features and then compiled in the end. In our team, we have myself, that is Tanisha Chhabra, and Nishant Upadhyay. So I have worked on the crawler and the file parser, and Nishant has worked on the try initializer, page ranker, and the web search engine frontend. So now let us get started with the brief introduction about the project. So the web search engine that we have developed is a part of the final project for our course, and it has the capability of searching words in HTML files present on the web. As a part of features, we have written a web crawler that reads files and finds the URL links present in the web pages. The HTML file parser then reads the web pages that were created and creates text files of them. The try initializer then creates a try symbol table that contains the words and the references where the word is present. Now let us see what exactly is a web search engine. A search engine is a software that helps to find information over the internet or the World Wide Web whenever the user inputs some keywords or phrases. The important part of the web search engine is to produce relevant collection of search results that respond to the query that the user has provided. Search engines are able to show the user the web URLs that contains the word or the phrase they are searching for. Now these are the features that we have covered in this project, that is the crawler, HTML parser, try initializer, page ranking, web engine, frontend. Now I would like to explain about the web crawler. A web crawler is a type of an internet bot that is operated by the search engines such as Google, Yahoo, Bing, etc. The web crawler we wrote takes in a start URL and then fishes for URL links in the web page. It then recursively visits the web pages and scans the URLs present in the web pages. We have used JSOAP library to read the web pages. The web crawler calls the file parser to parse the HTML pages of the web and converts it into text files. We have kept a depth of 25. It runs as a separate thread continuously while sleeping for 2 seconds in between running for 30 seconds. Now I would like to explain the HTML file parser we have implemented. This file parser uses JSOAP to read the contents of a URL and then creates text files which is then stored in a local storage. This file parser is called by the web crawler which passes the URL to be parsed and converted to the text files. So now I would like to hand over to Nishant, who is going to explain the rest of the features along with the live virtual demo of this project.
Hello everyone, I'll continue with try initializer. The try initializer feature. The try initializer feature reads the files from the local storage and gets all the words, and then it creates a try. It is a 26 to 56 way try that we have used so that all the Unicode characters can be stored. And each word in the try has a value of array list, which will have the reference and the count of the words stored. Inverted, we have used the inverted index implementation so that for each word we can get the references where the word is stored and the frequency count of the number of times the word is stored in each reference. The page ranking features sorts the URLs on the decreasing number of count of words. So it sorts in the decreasing order. I mean, the URL which has the maximum number of words is shown first. The web engine is the front end of the product. It gives the users options to search for the words in the web. This is the flowchart of the application. We first start the crawler, and the try initializer runs in separate threads. The crawler is run in a separate thread. It reads the web pages to get the links, and then calls the HTML parser to pass the URLs. And the HTML parser writes the creates a text file of the text in the URL, and it stores at a location. Let's say the location is X. The try initializer reads all the files present in the location X. It gets all the words, and then it adds those words into the try. It loops through all the words and adds those words into the try. If the word is present, it increases the number of count. Otherwise, it adds a new reference, and this happens for infinite time. Both of the threads run for infinite time. We also have the front end. The front end is where the user has the option to search for words. When the user enters a word to search, we look into the try, and if the word is found, we sort the result in decreasing order of the number of occurrence of the word, and then we show the result. And this again goes back and it continues. If user chooses to exit, the application stops. Let me show you a live demo of the application. Uh, so I'll first show you the crawler, and then I'll show you the try initializer, then we'll see the front end. The crawler is run in a separate thread. For demonstration purposes, we have kept a main method, and it starts the crawler thread. The crawler thread then when the thread starts, the run method is called, and there is an infinite loop which calls the start crawling method, where the crawling happens. I mean, it gets the URL, and it recursively calls the start crawling method with the new URLs. When the start crawling method returns, the parse URLs method is called, and in between the thread sleeps for 2 seconds. Let's take a brief look at the start crawling method. The start crawling method takes a URL and a depth. It gets the links in the web pages, and it iterates over those links and recursively calls the start crawling method with the links. If the time elapsed is 30 seconds, that meaning to say this start crawling method has run for 30 seconds or more, it will return. So this start crawling method will never continue for more than 30 seconds. Let me run the crawler and show you the how the files have been written. Let me also tell you that when the start crawling method returns, it calls the parse URLs method. The parse URLs method calls the HTML parser and passes the URL as the argument. The HTML parser will take the URL, read the URL, get all the text, and call the write text file method. The write text file method writes the text, creates a text file with the text as the content of the file, and the file name is the URL. File name of the text file is the URL which is being written as text file. So I have started the crawler in this location. Pardon me. The crawler is writing the text file. It is running in an infinite loop, and more text files are being written. If I delete all the text files that were written, we can see that more new text files are being written continuously. If we see any of the file, we can see that the text is being written. I'll stop the crawler for now, and we will see the try initializer and I will show you the try initializer implementation. So this try initializer is also written in a separate thread. For demonstration purposes, we first call the crawler thread. so that it writes the text files in the location, and the try initializer thread is then started. When the try initializer thread is started, the run method is called, and the create try method of try initializer is called. The create try method will get all the files in the directory, and then it will get words in the file. For each word it will update the try. If the word is present, it will add new, it will update the reference, the count of the reference. Otherwise it will add a new reference. Also, when the try calls the get words in file method, the get words in file method reads the file present in the directory, and after getting using string tokenizer, when it has read all the words, it will delete the file from that directory. Let me run the try initializer and show you. So the try initializer is run in this location. Since when we run this try initializer, the crawler thread is also started. After a few seconds we will see that the new text files are being written here, and the new text files that are being written after a few seconds will be deleted, because the try initializer thread will read those files and delete it. We will wait for a couple of seconds, before which the crawler will start writing the files. Now the crawler has started to write files here. The crawler is calling the HTML parser, and actually the HTML parser is writing the files. And now see, the try initializer has read those files and deleted it from the location. Now if we go and search for a word, we will get results for that. Let me now go ahead and show you the front end of the application. This is the front end of the application, the search engine. It says the user enter your choice, search the web. User enters number 1 and the word to search, about. The user gets the results. The user can search for more words like read. So read is not present right now. Let us see what, okay. Let us see if more files are being written or not here, because the crawler has started and the crawler is writing text files here. If we go to any of the text file and see what is the content of it. Okay, once, sorry. If we take any of the word like guest and search for it, then we will find the results. So we will wait for the files to be deleted, so that we know that the try has been updated, and we will again search for the word like read, or if we go for another word like policies, if we go and see, like if we look for ensure, we see the results. These are the search results we got for ensure. These are actually web URLs. If we try to hit this web URL on the web page like this, and we search for the word ensure, we see that the word ensure is present in the website. So our web crawler is our web engine is actually searching for words on the webs on the internet. I'll pass on the presentation now to Tanisha to carry it forward.
This was the virtual demo of our project, and now I would like to discuss about the future scope of our project. In the future scope, we are planning to add the following features to the project. First one is that we are going to implement the search of phrases in the web pages. Secondly, in order to make the web search more interactive and user-friendly, we will integrate the user interface. The last one is the auto suggestion of queries. These are some of the references used throughout our project. Thank you.